Okay, so let's solve this question. The question states that consider the following code snippet. This code snippet is given to us. Okay, using the fork and wait system calls. So these fork and wait system calls, I do hope that you remember the exact behavior of both these system calls need not be exactly memorized to solve this question. The base level behavior, that fork commands, basically the single thread that is coming, the fork command is going to produce a child thread, and the current thread is going to go on. This current thread is known as the parent thread, and this child that is being created is known as child thread. Okay, and the wait null command, as is used over here, basically makes the parent wait. The parent is going to come, the parent thread is going to go over there, and then it's going to wait till the child thread has finished. That's the fundamental behavior of this fork and wait. As you can see, this is not the exact behavior mentioned on the site, because the site has a bit more mentioned, because sometimes these system calls fail when they are called because of current system dynamics of the operating system, right? So they may fail. For that failure handling, there are certain more behaviors that are part of both of these, but they are not considered right now, because here in the question they have given that the code compiles, runs correctly, and the system call run successfully without any errors, right? Because of this, both of these system calls have been immensely simplified, and their behavior pertaining to its maintenance when the system call fails has not been considered. A lot of dynamics has been skipped, right? So that part I do hope that you are able to follow. Once that part is very clear, operating system concepts, right? From that operating system concept, some kind of mathematical model has to be made, because it's a 2-mark question. A bit of twist is always present, right? And what is that twist? The twist is a system that this in this code, at this fork and wait is present, inside there is a printf statement. And what is this printf statement concerning to us? As far as the question is concerned, the number of times the printf statement is executed is, we have to count this printf statement and how many times is it executed, right? So this kind of, because the number of iterations is very less, because x is equals to 3 and x is going to iterate till what? The iteration is going to last from 3 to 1. So you can directly solve it by just writing down the iterations and solving it like that. Not very difficult, right? I mean, if you have solved programming, then you must know that the condition of the while loop really goes on to give you states in which that while loop is going to execute. That this piece of code is executed multiple times because of the loop. That is the purpose of the loop. But the only difference between each execution of the loop is the state variables, right? And basically the variables that we have defined, and the condition that the current variable are in. Right? So the condition of the variables dictate how the current while loop iteration is executing, right? After the while loop, there is nothing. So after the while loop, the code is basically over. So we have to count the number of iterations. We have to consider the number of iterations in which this while loop is executed, right? At first, x is equals to 3. This is one domain in which the loop is going to execute. Okay. After that, there is the domain of x is equals to 2. After that, there is a domain of x is equals to 1, right? And after that, at the very end, x is equals to 0. At this, the loop basically ends. Whatever thread goes beyond this point comes over here, we're going to directly mark it as end of the thread, right? That is the basic essence of it, in which the loop is concerned. Okay. Now we start with the parent thread. The parent thread starts over here, right? It comes here. At this point, at this fork, it is going to produce a child thread, and it is going to move forward, right? Oh, no, this is not very clear, right? I have so many space, why I'm wasting so much. So parent comes over here, it produces a child, it goes on like this, it goes on like this. Let's suppose that this circle dictates printf, the printf part. Okay, so both the parent and the child is going to come to this printf, and they are going to print hello. Fine. After that, the parent thread is going to encounter the wait, and it is going to start waiting at that point. But the child thread is not blocked because of this wait. Okay, so it is going to pass through to the next iteration where x is equals to 2. Okay, at which point it is going to again fork out, and then it is going to come. The parent thread is again going to print. Likewise, the child thread is again going to print. The parent is going to get blocked. Over here. Let me just make it a block, and then the child thread goes on to the next domain at which x is equals to 1, the next iteration, right? This decrement over here is producing the shift between the ranges from x is equals to 2 to x is equals to 1 for a particular thread. I do hope that you follow that, right? Once the child comes to x is equals to 1, as the breaking condition for this loop is for x is greater than 0, right? This is the break condition of the loop. Let me place it over here. This is the break condition. Break condition. Right, break condition is present over here, right? At this point, because x is equals to 1, it is the break condition has not been met. So again, the same kind of pattern which was here and here is going to repeat itself. Okay, so it is going to produce a child, and that child and the current parent is going to print out, and then the child is going to go through the basically decrement of x, and then at that point, because x is equals to 0, the break condition has been met, so the child thread is going to die. At this point, its parent, which was waiting currently, is going to activate, because the wait null command right over here is going to wait, is only going to make the parent wait till the child is not exited, right? So once the child has exited, the parent will basically will be reinitiated, is going to come to life, and then it is going to execute the rest of its commands, right? Because x is equals to 1 is present for the parent, right? And the wait goes out, x is decremented, and then the while loop is over. That is the behavior of the parent. Okay, that is going to happen over here, and the parent dies. Because this parent over here was a child over here, right? So this child thread has basically died. So this wait is going to start executing, right? And I would like to say at this point, right, because we as humans can perceive patterns and possibilities, just see the pattern that is happening at which x is decrementing, right, and coming to the state x is equals to 0, x is equals to 1, right? From x is equals to 2 to x is equals to 1, that is the change of state, right? And this thread is coming over. Is this thread in any way different from this thread? No, it is exactly the same thing, right? Because there are no other variables being considered, and there no other values impacting it other than x is equals to 3, and that is the only state, the current state defining element. Because this state has been reduced from 1 to 0, no, not from 2 to 1 over here, its behavior is completely equivalent to this thread as it went about, and we had already considered all of that, so we can directly go on and point that it is going to go on like this. Likewise, when this thread dies, this particular thread right over here is going to die. This thread is going to be dead at that point, right? This thread is going to be dead at that point. So this particular parent is going to be activated. Exact same behavior, right? So we don't really need to calculate all those things. We can directly apply it at that point, right? At this point, if you are very familiar with function dynamics, I'm going to show that also, that aspect also. You can apply that aspect and solve it very quickly, or you can directly count about the number of times printf has been printed from the information that you already have, right? 2 times it is printed right over here, right? So 2 times it has been printed. Now for right over here, 2 times more we can add 2 times more, but because this thread also shows the same behavior as is present over here, right, the previous 2, so we can multiply it by 2 and just add it about. Likewise, when it comes over here, 2 times is going to be printed for this x is equals to 3 also. So 2 plus, and because this thread is going down 2 times like this, right? So 2 times this whole thing, that is going to be giving you your answer, right? And what is that giving you? 2 times, this is 4, 6 times 2, 12, right? So 12 plus 2, and that is 14, and that is going to be your answer, right? This question you have basically going to get answer 14 very easily. You can also apply functions over here to solve it very from a mathematical point of view, because the x is the only state defining element over here. You can define that the number of time printf is executed for any x be defined by f, right? F of x gives the number of times printf is executed, right? If that is the definition, right? So for f of 1, we can get f of 1 is equals to 2, we can get from the empirical data, from the data that is present by the fundamental analysis, right? And then from at the very top analysis, I can see that 2 times it is going to, for any element x is equals to any n, right? Any n. Let me draw that out. Let's say x is equals to any n, right? It is going, parent is going to fork out into a child and into a current element, both of the current parent thread, right? Both of them are going to print out, going to produce two printf statements, and then at that point the parent is going to stop and wait for the child, and then the child is going to go on till x is equals to n minus 1, right? This is not very clear, n minus 1, right? With that being present, and then the parent is going to follow like this, and it's going to show exact same behavior, right? Let's assume that f of n minus 1 is already known. Can we express f of n in terms of f of n minus 1? Yeah, obviously we can, because f of n by itself produces two printfs independently, and then it produces 2 times of whatever f of n minus 1 produces, right? I do hope 2 times f of n minus 1 is very clear, because one time the child thread is going over here, and then the other time the parent is also going over there, right? So this is very clear. Once we have this part and we have the empirical data of f of 1 is equals to 2, we can directly apply f of 2 is going to be given as what? 2 times f of 1, and that is 2 times 2, that is 4, plus 2 is 6, right? Likewise, f of 3 is going to be given as 2 times f of 2, this is 6, this whole thing becomes 12 plus 2 is equals to 14, right? So we can apply functions over here, because when you apply functions now, you can actually make it accelerate, because now I can directly go on with the function statement iterations and get to a bigger number. Let's say f of 5, f of even 9 and 10 can be done if you go on like this, right? If you are very familiar with series kind of dynamics, you can even go it till f of 100. But with this, because f of x is equals to 3 was the maximum value, so you can also count it about like I did over here. But even in counting, I did not do it multiple times, because the stuff that I've already solved, always try to use it, because that really reduces the time that you require to solve a question, right? And that's kind of the whole thing. The only part over here that I really want to emphasize regarding operating system is at certain times the system calls may show failure, right? So the reason we can simplify it to such a extent, a system call being incorporated in our code, is because of the fundamental assumption that they pushed forward, that the system calls are not going to fail at runtime. Compilation and runs are very easy, but system calls sometimes failing, and their handling makes software engineering sometimes very complex, and that part has been simplified by the assumption that has been posed, right? And with that, I do hope that you learned something, and I will see you in the next video. Thank you.